Alright, again, before we go into conics, just going to go through another very quick video on some more circle equation stuff. These are some skills I want you guys to really have down pat before we really dive into our conics. In the first video, we looked at the equation of a circle, where HK is the center and R is the radius, and how it related to our graph. In this video, we're going to take a look at a little bit more in-depth versions of that skill. So in this quick example here, let's plot a center and a point on the circle, and we'll see if we can't write the equation of this circle. Center is at 8, -9, so that's going to be over here. Point on the circle is 4, -7, so that's going to be right here. So this is our center, and this is our point on the circle. First thing, of course, we want to do is figure out the radius of our circle. The radius of our circle is essentially going to be the distance between those 2 points. So let's get our distance formula going. And I'll go really fast here since we did this in our first video in this section. So we're going to take the difference of the x's, 4 minus 8, and the difference of the y's, -7 minus -9, and we're going to simplify. That's -4 quantity squared, and that's +2 quantity squared. What we're doing here is finding the radius between the center and the point on the circle. So it's the square root of +16 plus 4, which is the square root of 20. The square root of 20 is your radius. In our formula, in our circle formula, we actually want to take radius squared. So if you square that, you just get 20. The square root of 20 squared is just 20. X minus h, h is 8, plus y minus k, which is actually a +9. And there's your circle equation. Moving on. What is the equation of a circle whose diameter has endpoints 3 positive 6 and -1, 5? So I'll plot these. 3 positive 6 goes up this way, and -1, 5 goes right here. Now those are the endpoints of the diameter. Endpoints of the diameter. So maybe we should connect those dots, and that'll give us our diameter. So that means our center is somewhere right around in here somewhere, and our circle would go something like this. So we need to write the equation of that circle. In order to write the equation of the circle, we need a center, which is h, k, and we need a radius. Alright, so if the diameter has endpoints of 3, 6 and -1, 5, that means the radius should be half of that distance. So first things first, let's find the distance of our diameter. So the diameter is given by this distance. So we're going to take our x's, 3 minus -1, and our y's, 6 minus 5. I'm going to find that distance. That's 4 squared plus 1 squared. So this is the square root of 16 plus 1, which is the square root of 17. And what we're going to do is, that's our diameter, so that's d. A radius is half of that. So we're going to say it's the square root of 17 over 2. Alright, that's kind of strange, but it's not too bad when we actually put it into our formula, which we'll see in a second. The center, as I said, is around right here, but we need to find the exact point at which that center resides. So to do that, we're just simply going to find the middle of the 2 endpoints of the diameter. Midpoint formula is really simple. You basically just take the average of the coordinates 3 plus negative 1 divided by 2, 6 plus 5 divided by 2. So our midpoint, which we'll call our center, 3 plus negative 1 is 2, over 1 is 1. 6 plus 5 is 11, over 2 is 5.5. And that visually makes sense. 1 to the right and up 5.5. So that makes sense. It looks good to me. Alright, so these are the two things you need to write the equation of a circle, the center and the radius. So let's actually translate this information to our circle equation. So I'm just going to kind of bring it down here, give myself lots of room, and here we go. The circle equation says r squared is equal to x minus h quantity squared plus y minus k quantity squared. So r is the square root of 17 over 2. We're going to square that. X minus 1 quantity squared, y minus 5.5 quantity squared. This whole right side can't be simplified anymore, so let's just work on the left hand side. What we want to do is take the square root of 17 over 2, multiply it by itself. When you do that, you get the numerator to be just 17, the denominator is 4. 17 over 4 is r squared. And just rewrite everything else. And we are done. So this is our answer. Not as nice and neat as some of the other ones, but it's okay. And as always, if you wanted to change this fraction into a decimal, you certainly can. That would be, let's see, 4.25. Alright, so there's some more review, some basic stuff. How about this one? What is the radius of this circle? And remember, the circle equation usually has a coefficient of 1. The x squared and y squared terms have coefficients of 1. So when you're presented one that does not, you of course need to get rid of that coefficient that is not a 1. So just divide everything by it. So what that'll do is leave you with this, is equal to 80 over 4. So these are going to cancel, turn into 1s, so it's x squared plus y squared is equal to 20. 80 over 4 is 20. And that sort of translates, if you remember, that translates into r squared. So r squared is equal to 20. To solve that, you take the square root. So your radius is the square root of 20. But we want to, whenever possible, simplify those radical expressions. So we take 20 and bust it up into 4 times 5. Our radical rules, split them up. Square root of 4 is 2, and radical 5. So there is the answer to the question, 2 radical 5. It's a heck of a lot better than leaving it in this form, and it's certainly better than using your calculator to get a decimal, because it's not going to give you an exact answer. To get some more practice with that radical simplification, try these. Pause it right here and try to simplify these radical expressions. Try to get them down into their simplest versions. And to do that, what you want to do is look at your radicand, the number underneath the radical, and see if there are any perfect squares inside of it. See if you can find factors that are perfect squares. So let's see, 1 times 108, 2 times, let's see, 54, that's not a perfect square. 3 times 36, I believe, yeah, that works. That's 90 plus 18. And that's good because 36 is a really big perfect square. So I'm going to bust this up into this product, 36 times 3. I'm going to write the perfect square first. I'm going to break it up like this, separate the radicals. The square root of 36, I know, that's 6. Get rid of the radical and just put radical 3 at the end. We don't know the square root of 3, so we just leave it like that. So that is equivalent to the square root of 108. It's just a much more simplified version. It's nicer. All right, let's try this one. We have 98 as a radicand, so I'm going to bring that over here. 98 is, let's see, 1 times 98, 2 times 49. That's good. 49 is a nice big perfect square. So I'm going to write -7 times the square root of 49 times 2. Let me give myself a little bit more room here. See if I can't bring these down a little bit. There we go. And a little bit more room maybe. So we have -7 times the square root of 49 times the square root of 2, which is -7 times 7. Notice when you actually perform the operation of square root, you get rid of the radical, times radical 2. So that's -49 radical 2. We can multiply the numbers on the outside. So -49 radical 2 is equivalent to this thing. It's just a nicer version. Alright, let's try a couple more here. Let me make a little bit more space. So here we have a radicand of 50. So I'll bring it over here and I'll say, alright, that's easy. That's 2 times 25. So this is going to be 10 radical 25. Let me write that a little bit better. Radical 25 times 2, which is 10, split them up, which is 10 times 5 radical 2, which is 50 radical 2. So there's a nicer version for you. Almost done. We have 8 radical 12. 12 is not a perfect square, but it has 2 and 6. That doesn't help us. It has 3 and 4. 4 is a perfect square, so let's break it up in that manner. 4 times 3, 8 radical 4 radical 3. So it's 8 times 2 radical 3, which is 16 radical 3. That's equivalent to 8 radical 12. Alright, last one. We have radical, let me move this over a little bit. We have radical 90 and radical 40. Alright, so that's interesting. They're not the same, but let's just work on them separately. So I'm going to take 90 up here. I'm going to think about the factors of 90, the numbers that multiply together to get 90. It's 1 times 90, 2 times 45, 3 times 30, and let's see, 5 times, nah, that's not going to work. Well, how about this? How about 10 times 9? That seems pretty easy, right? 9's a perfect square. So I'm going to rewrite this, -15, radical 9, radical 10. 40 is going to break up into, of course, 4 times 10. 6 radical 4, radical 10. So it's -15 times 3, radical 10, plus 6 times 2, radical 10. That's -45, radical 10, plus 12, radical 10. Since they both have the same radicands, you can simply just add the numbers in front, sort of like coefficients and variables. So it's going to be -33 radical 10. So believe it or not, this craziness simplifies to that. And you can confirm that with a calculator if you'd like. But all the math works out. Okay, so there's some sort of side practice there for you on radical simplifications. Alright, let's do this one. Getting back to our circles, we have, what is the equation of a line that is tangent to this circle at this point? Alright, first things first, let's plot that point. I'm going to put that point in red. It's 5, 12, and that seems to be right here. 1, 2, 3, 4, 5, up 12, yeah. And the circle this circle has a center of 0, 0 and has a radius of 13. Alright, so if you were to graph this circle, the center would be here and the radius would be, of course, right here. And the circle would be really big. Right, to go around here or something. So our job is to figure out a line that's tangent to that circle. So again, the circle would kind of come this way and sort of go that way, something like that. So the line that's tangent to that circle, it touches at that exact point and goes through and only connects at that point. Now, that's not a very good job drawing that, so I might see if I can't move it a little bit. That's probably better. Let's see if I can't straighten it out too. Sometimes this works, sometimes it doesn't. That looks pretty good. And that has arrows on it, right? That's a line, that's a tangent at 5, 12. And our job is to figure out the equation of that green line. Well, equations of a line basically just need your slope and where your y-intercept is. So our slope is pretty simple. Our slope is going to be, let's see, if we have any sort of recollection of what it means to be a tangent. Tangents are perpendicular to the radius at that point of tangency. So if you're looking at a circle and you have a point of tangency, there's a radius that goes to that point that's perpendicular to this tangent line. That's the sort of the rule. So if we figure out the slope of this radius, we should be able to figure out the slope of our line by taking the negative reciprocal or the opposite reciprocal. So what is the slope of this radius? Well, the slope of that radius is simply just rise over run. How much does it go up? Well, it goes up from the center to here 12, it goes up 12, and it goes right 5. So the slope of your radius, m sub radius, is 12 over 5. And that means the slope of your tangent line is the opposite reciprocal of that. So that's going to be the slope of our tangent line. And the y-intercept, as you can see, is somewhere up here. Looks like it's about 14.5. We're going to find out exactly what that is. So we're going to say, all right, y is equal to m x plus b. And the y and the x, of course, to figure out the b, the y and the x come from this point where 12 is y and x is 5. So here we go. We're just going to simplify that. We have 12 is equal to negative 25 over 12 plus b. I'm going to get rid of this so we can get some more space. And we're going to add 25 over 12 to both sides. We're just going to add it to both sides. You might want to take some common denominators here. We're going to convert 12 into something over 12, which of course is 144. So 144 over 12 plus 25 over 12 is 169 over 12. That's equal to our b term, our y-intercept. Now we want to make sure that we simplify that. If you wanted to convert it to a mixed number or a decimal, that might be a good idea. And you'll find out that it's irreducible, doesn't share any common factors, numerator and denominator. So if you wanted to turn that into a mixed number, it'd be 14 and a 12th, which confirms for us what we sort of suspected. The y-intercept is up here, about 14 and a 12, 14.08 around. So we just bring that back up into our equation, plus 14 and 1/12, and we're done. That is the equation of the tangent line to this circle at that exact point of tangency. And try this one. Using the same strategies. Write this down, pause it, see if you can figure out the equation of the line that's tangent to this circle. And of course you probably know already that you have to divide everything by 2 first at the point 24, 7. So go ahead and pause that and give it a shot. And since this video is getting a little long out of interest of time, I just went ahead and finished this for you. Your final answer is here in yellow. You can see that the y-intercept is really, really big because the slope of the tangent is pretty severely negative. So anyway, I hope you found this video to be pretty helpful. And if you're a geometry student, you're probably doing a lot of this stuff. If you're a pre-calc student, this is really prepping you really well for all the conic section stuff that we're about to get into. So thanks for watching.